This is an example of a classic but very simple Bayesian network model, sometimes called the Asia model or the chest clinic model. What you can see here are nodes or variables, which in this case, for simplicity, just have two states. So yes or no for smoker, yes or no for bronchitis. Dyspnea is a symptom, shortness of breath. Now the idea of this model is that we're attempting to diagnose whether a patient entering a chest clinic has one of these conditions or none of them, tuberculosis, lung cancer or bronchitis. And we're going to do that by asking questions about their background risk factors, by observing symptoms like this, and possibly by doing a diagnostic test like an X-ray. The point is that all of these variables may or may not be observed. We're unlikely to observe these. We're going to try and infer them from what we observe about the other variables. There's a directed arc between two nodes, like smoker to lung cancer, if there's a direct causal or influential relationship between them. So we know that there is a statistical relationship between smoker and lung cancer. So smokers tend to be more likely to get lung cancer than non-smokers. And the strength of that relationship is captured in what we call the node probability table. So what it's saying here is that if a person is a smoker, then there's a 10% chance that they'll have lung cancer. And if they're not a smoker, there's a 1% chance they'll have lung cancer. The point is that it's still unlikely that they're going to have lung cancer, whether or not they're a smoker, but it's a bit more unlikely if they're a non-smoker. This particular node here is just to make things a bit simpler. So this is tuberculosis or cancer. This is just saying if you've got one or the other. So if we're looking there, that is simply a deterministic relationship. So this is true if either one of tuberculosis or cancer is true. So if either of these are yes, it's true, and if both of them are no, then it's false, it's no. Now if I double click on these, then what is shown are the so-called marginal or prior probability values. So we're assuming that, presumably based on data of the chest clinic, that 50% of the people who've been into this clinic are smokers, 1% have recently visited Asia, etc. Now what's going to happen is that as I enter information about a particular person coming into the chest clinic, that Bayesian propagation is going to be applied automatically to update all of the unobserved variables in the model. So if, for example, I enter the observation that this person is a non-smoker, and I run the model by clicking this thing here, then you can see that all of them change except for this one, because these are kind of like independent. So what we're seeing now is that this person is not a smoker, so all of these probabilities of any of the conditions go down, is unlikely to have any condition. But let's suppose that this person is reporting shortness of breath, dyspnea. If I now run the model again, it's now doing back propagation, and it's drastically increased the probability that this person has bronchitis. The other two are extremely unlikely. So at this point, the most likely diagnosis is bronchitis. But let's suppose that we decide that we're going to send this person for an X-ray, and the X-ray comes back positive, so it's a positive X-ray. We run the model again. What that has now done is decrease the probability that the person has got bronchitis and increase both of these probabilities, because the positive X-ray is more likely to be observed with tuberculosis and lung cancer. However, at this point, if we had to make a diagnosis, bronchitis is still much more likely than any of the others. We then discover, suppose, that this person had a recent visit to Asia. That single piece of extra information changes everything. Suddenly, from nowhere, tuberculosis becomes the most likely diagnosis. And there you can see the example of both a forward and backward propagation that you can do in a Bayesian network. I'm just going to remove all of the observations here. Run the model again. Back to the start state. I'm going to show that in AgenaRisk you can also do sensitivity analysis over a model like this. So now I'm going to launch the sensitivity analyzer by clicking this icon here. I'm going to select lung cancer as our target node. Select all of these, let's say, except for that one, it's not interesting. Select tornado graph, and there you can see it generates the tornado graph in a web browser. So the positive X-ray has the most impact on probability of lung cancer being yes. Visit to Asia is almost irrelevant in terms of sensitivity for lung cancer. Let's now compare that in the case where we run the sensitivity analyzer now for tuberculosis, the target node. Do the same thing again, run the model, and now positive X-ray is still important for that, but the visit to Asia now becomes the second most important node in terms of sensitivity analysis. Anybody can open and find this model by opening the model library on AgenaRisk. And you'll find it in tutorials, and there you'll see Asia. When you open it, there's the model.